Hello, this video will hopefully give you a conceptual understanding of what a mole ratio is. So before I talk about chemistry, I'm going to talk about baking, because people seem to have a better intuitive picture of putting together ingredients to make a cake than mixing together a bunch of compounds to make a new compound. Which is really, making a cake is just making a compound. These are a bunch of chemicals, and this is just a bunch of chemicals stacked on top of each other, but it's a lot easier to understand it when you pretend like they're not chemicals, and you pretend like they're just eggs as an element, I guess. Whatever. So, let's say that you want to make this cake, this delicious looking chocolate bundt cake. You need to add these ingredients, and it's really easy to do because it tells you exactly how much of each ingredient to add. You add 8 ounces of butter, 1 teaspoon of salt, 4 large eggs, 1 teaspoon baking soda, etc. But let's say you don't want to make exactly this cake. Or rather, you do want to make this cake, but you want to make one that's twice as big. You have a very big party coming up. This is not enough. You need to make more. So you want a bundt cake that's twice as big. Well, how would you do that? Just using this recipe. And it's not that difficult. You would say, well, the recipe tells me 4 eggs, but I want to make one that's twice as big, so I'll do 8 eggs. That makes sense. And it says I need 1 teaspoon of salt, but I want to make a cake that's twice as big, so I'm going to add 2 teaspoons of salt. And let's do one more. 8 ounces of butter. Well, we should add 16 ounces of butter because we're doubling everything to make a cake that's twice as big, right? The way that you figure out what to do to every ingredient is you just sort of double it. It's very important that the ratio of the ingredients remain the same. Imagine how disastrous it would be if, in trying to make a cake that was twice as big, you doubled the amount of salt, but you didn't change the amount of eggs, and then you made the amount of butter you use go down by a half, so you only added 4 ounces of butter. If you mess with this ratio, you're not going to get this cake. You're going to get something else, probably something very nasty. If you want to make a cake that's half as big, maybe you don't need to feed a whole person, right? You're just feeding like a little kid. I guess little kids are people too, whatever. So let's say you want to make a cake that's half as big for whatever reason. You would use 2 eggs, and then a half a teaspoon of salt, and then 4 ounces of butter. If you only halved the amount of eggs and nothing else, once again, you would get not what you wanted, which is a small cake. You would get some nasty conglomeration of weird ingredients. So no matter what you do to this recipe, you have to keep the ratio of the ingredients the same if you want to make sure that your product is going to be what you want and not some random nasty thing. It's very similar in chemistry. When we mess with the amount of a product we want to make, like we want to make twice as much ammonium, maybe, or half as much, we need to make sure that the mole ratio is the same between all the different ingredients, the products and the reactants. They have to be in the same ratio, otherwise we're going to make something we don't want. The way to figure out the mole ratio is pretty simple. You look at the recipe. Now this right here is a recipe. It's what to do if you want to start with KClO3, which is potassium chlorate, and you want to make potassium chloride and oxygen gas. Now these coefficients in front are very much like these numbers in front of the recipe. This tells you how much butter you should add. This tells you how much milk you should add. Well, right here, this tells you how much potassium chlorate you should add at the beginning, and this tells you how much oxygen you're going to make at the end. It's just a recipe. Now, one key fact about figuring out a mole ratio is that it's a ratio between specific elements, not between everything in the chemical reaction. Not specific elements. I guess I should say specific compounds. Like, for example, here, right? If I wanted to figure out an ingredient ratio, I would have to figure out the ratio of maybe eggs to salt. And the ratio of eggs to salt would be 4 to 1. Now, if I wanted to change the amount of cake I made, I could maybe use 8 eggs and 2 teaspoons of salt. This is okay, because this is the same as the ratio 4 to 1. That's fine. This is going to make a good cake. But I can't just do 16 or 18 to 2, right? Because if I add 18 eggs and 2 teaspoons of salt, this no longer matches the recipe. And so I'll make something that's not this delicious cake. I'll make some random pile of goop. So the key fact here is that a mole ratio is the ratio between 2 specific compounds, and you get the mole ratio by looking at the coefficients or the little numbers in front of the chemical equation. Just like up here, we looked at this 1 and this 4, right? This 1 and this 4 told me what the ratio of ingredients should be. If I'm looking here, I have to figure out the ratio between potassium chlorate and oxygen gas, maybe, by looking at the numbers in front. So the way that you figure out the ratios is by doing this. You just look at the coefficients, and then what a ratio is a fraction. So I'll just do this, and maybe you'll be able to see the pattern. The ratio between potassium chlorate and potassium chloride, I figure that out by figuring out how much potassium chlorate I have, and I have 2 molecules of potassium chlorate per the amount of potassium chloride I add, which I look up here for the recipe to tell me it's 2. So the mole ratio between potassium chlorate and potassium chloride is 2/2. 2 of these for 2 of these. I could simplify this if I wanted to, but it's not even necessary. You could leave it like this and that's fine. The mole ratio between potassium chlorate and oxygen, I figure out a pretty similar way. I figure out how much of this I add, and I look at my recipe to figure it out. I add 2 of these, then I figure out how much oxygen corresponds, right? So I figure out how much oxygen corresponds, and I look at the recipe, and I have 3 molecules of oxygen for those 2 potassium chlorates, so I have 3. And right here, the mole ratio is 2 of these to 3 of these. That's simple enough. Finally, at the end, you have potassium chlorate, or potassium chloride, that's what this is, KCl and O2. You figure out what the ratio is very similarly. You say what I have is I have KCl, and I want to know the ratio of KCl and O2. So I look up at the recipe, and I say I have 2 KCl's for every 3 O2's. And that's it. It should be very easy to figure out the ratio, which is this fraction. Remember, a ratio is a fraction, based on the recipe, by just looking at the coefficients and putting them in the right place. I hope this was helpful.